Hello, and welcome to the screencast to walk through the results of exam 2. Remember now that for this exam, except for task 1, everybody's solutions actually should be a little different. So I'm going to walk through one example of what it might look like. Depending on what your sample was, you might have different results. But I'm hoping that you understand the process we were looking for here and the kind of connectedness of all the different tasks here as a good summation of what we've done so far in this course. So for task 1, we were to find the mean, median, and standard deviation of both the students' GPAs and SAT scores separately from the data listed here. And based on the mean and median, provide a description of what you would expect their histograms to look like. This was a key one here that many folks missed. So on this second tab here, I have the data. If you recall here, we had 3 columns, one for the student number, one for the GPA, and one for their SAT score. So for task 1, I went through and used the descriptive statistics tool to produce the mean, median, and we also wanted the standard deviation of each of these. And so these are the solutions here for task 1, at least for responding to what the mean, median, and standard deviation were. But then the second part was they provided description of what I would expect the histograms to look like. And due to the fact that the mean for each, the GPA and the SAT scores were less than the median, then I would expect the tail, I would expect it to be skewed, and the tail or the skewness going towards the left or in the negative direction. Remember now, any outliers are going to pull the mean down away from the median, and that produces that tail that kind of in the skewness. So that was task 1. In task 2, we were to use the random number table in the back of the textbook, and I used I just chose row number 20, and row number 20 produced the student numbers that I have highlighted here in blue. And the task was to come up with 20 randomly selected students out of this group. And what you do again is, and I used column or row 8, row 20, and I went left to right. And say, for example, the number 05 came up. At some point, 05 came up. And 05 indicated that I wanted this person. Also, 17 came up. 23 came up. If, for example, 95 came up, and there is no number 95, then I toss that away and I select another person. And I kept going until I had 20 randomly selected out of this whole set. And then I put that here. So here are my 20 students and their associated GPAs and SAT scores. That was a key step that I saw a few people miss. When student number 5 was selected, both his or her GPA and SAT score must be selected with it. So it was important that back on this data set, when number 5 was selected, their GPA and SAT scores came with it. So now I have 20 students. Just being careful with Excel, I noticed that a few people ended up going down to number 20 here. Realized that row number 1 here is a student. So you actually ended up with 19 selected numbers. So you actually have to go one more so that we have 20 of them. So for task 2, it was to select those numbers. And there's my sample of 20 students selected out of that group. Your 20 were most likely different, unless, of course, and I think I saw one of you, used row 20 as well. So you ended up coming up with the same 20 students, which is fine. Task 3, we were asked to find the correlation coefficient of these 20 students, and we saw that there was a strong positive correlation. I used the correlation coefficient tool in Excel and came up with 0.85 or approximately 0.85. If you recall, I did ask that we round all of our digits to 20 decimal places. And so I rounded that to 0.85. Then the next step was to construct a scatter plot, which I have here, to then find a line of best fit. And you could do this by hand, and some of you did using the steps in the textbook, or you can put this on here and you can right click on the values, and then you can come up with format of trend line. And that's what I did, and I added this trend line. And when I selected the trend line, it also asked if I wanted the equation. So here is the equation of that trend line. I could also run a linear regression for these, and it kicks out this output down here. This was another way that we can do this. This is one that we're going to use later on in statistics too also. But you'll notice when we run that linear regression, this multiple R was in fact the correlation coefficient up here. And then you'll notice down here, the coefficients on this output of the intercept and the GPA. The intercept is our y-intercept, and the coefficient of the GPA here is our multiplier. So you'll notice this 33157 happens to be the multiplier here of the x in the equation, and the 74.39 happens to be the y-intercept here. That means that if we followed this all the way out to 0, that this would have crossed at around 74.39. So this is my equation then I needed to find for task 4. For task 5, we were to use this equation to then make a prediction for somebody who had a GPA of 3.25. So I substituted 3.25 into this formula, and you can use Excel as a calculator as well. So when I did that, I typed in equals into this cell, and I typed in 331.57, which I got here, times 3.25, which was the GPA of the student that we were predicting the SAT score for, and then plus 7.393. And I hit enter, and it produced this prediction. What we were not looking for, and it is a crude way of doing it, but we were not looking for you to find a value of 3.25 in here of the data points and then make a prediction from that. Some of you had students who had a 3.25 GPA, and you used their SAT score for the prediction. That's not what we were doing here. That is basically then finding the SAT score and GPA for a specific student. Here we were using our 20 randomly selected values to come up with a scatter plot and a line of best fit to make a prediction. So that prediction then was using the formula. So task 5, my prediction was 1151.99 as my prediction. For task 6, we were to be using the information from the original sample, this information here, to then find an upper and lower limit, just like one of the values in the textbook. And this gave me a lower limit of 1,043 and an upper limit of 1,210. And I would recommend using that one problem in the book that I alluded to in Slack to help following the steps for this. And then the last step was I had to then find the mean of my 20 SAT scores selected here. And my mean was 1,120. And we were wondering, is the mean from my selected 20 random samples within this range set from task 6? And this 1,120 does fall within these two values. And the idea was to kind of get you set up for what the next part of the course was, in hypothesis testing. Whereas if we were to conduct this 100 times, this little sample here, or if 100 students came up with 100 different samples out of our larger population, and we found the mean, that 95% of the time, the mean that we find is going to be within these two values, but 5% of the time is going to be outside these values we can expect. So hopefully that helped pull some of these things together throughout the course. And it also set a tone for hypothesis testing and what we're doing here for the second half of the course. So if you have any questions about the steps that we went through for this exam 2, feel free to email me. And hopefully this screencast helped.